All right, so today we are describing angle pair relationships. So we're talking about everything to do with angles that are next to each other. Now, on this first slide, I would like you to draw an angle. Any angle, could be acute, could be obtuse, and then draw a ray in between those angles. This is going to mean that these are adjacent. And that is exactly what we are talking about today. So go on to the next slide once you've done that. Angle relationships. So two angles that are complementary are two angles whose measures have the sum of 90 degrees. Supplementary means two angles whose measures have the sum of 180 degrees, okay? So complementary, I'm gonna go ahead and put this one in blue. That would be this angle down here. So angles 1 and 2 are complementary. Okay? Now, in red, supplementary. Supplementary angles are like the ones shown right here. They add up to be 180 degrees. Angle 5 and angle 6 are supplementary. All right. Now, one way that we can remember this, in blue, I will write complementary. You could think of the phrase, it is right to give compliments. Everyone loves a good compliment, right? And that's how you remember complementary angles. If you give a compliment, it's the right thing to do. That forms a right angle. And the other way you can remember supplementary with 180 degrees is think of supplementary straight line. Oh my goodness. Line. The SS. Okay? Supplementary straight line because 5 and 6 form a straight line. Adjacent. So adjacent angles are both complementary and supplementary, okay? Adjacent just means that they share a common vertex and a side but have no common interior points. So that means that the two complementary angles, angle 1 and angle 2, are adjacent because they share this side and none of their points are the same. 5 and 6 are supplementary and adjacent because they share that side. And then there's two examples of non-adjacent angles. Look at angle 3, look at angle 4, and look at angle 7 and angle 8. Okay? All right. Slide. Notice how the complementary angles here and the supplementary angles here are. Example 1, so it says use the figure to name a pair of complementary angles. So let's go ahead and name a set of complementary angles. All right, so the pair of complementary angles are, well, I see that 122 degrees is already bigger than 90 degrees because complementary, remember, it's right to give complements, so it has to give us a right angle of 90 degrees, okay? So that one's already too big, so we know we're not going to be including angle CAD, so we can take that one out of the question. But what we do want to look at is the other two. So let's take CB or CAB, angle CAB, which is the measure of it is 32 degrees. And then the measure of RST is 58 degrees. Okay? And when we add these two together, we're going to end up with exactly 90 degrees. So we can say that our complementary angles are CAB and angle RST. All right, so let's go ahead and find two supplementary angles. So supplementary means that they add up to 180 degrees. We can already see that these two, BAC and CAD, do not make a straight line. So let's go ahead and check out RST and CAD. Remember, it has to be 180 degrees. So, angle CAD, which is 122 degrees. This is the measure of that angle, by the way. And then the measure of RST, we already said, was 58 degrees. What happens when we add these together? You get... Would you look at that? 180 degrees. So what we can say is angles CAD and angle RST are supplementary. Why? Because their angles add up to 180 degrees. And then lastly, but not least, adjacent angles. So what we notice right now is the angle RST, this one right here, has no adjacent angles. It's not connected to any other angle. Now, what we do see is that these two are connected, CAD and BAC. So those are our adjacent angles. Angles CAD and BAC. Now, if we were to go adjacent, in this one, they are not, okay? Because RST is not adjacent to either one of these, but they can still be complementary and supplementary, okay? You do not need to be adjacent in order to be complementary or supplementary. All right, example 2, we've got some sports. So when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of angle BCE and measure of angle ECD. So I'm going to go ahead and start drawing on this image. So by supplementary, it just means that together they're going to form a straight line, which we see down here. And that line is line BD. Okay? So one angle would be DCE, this one right here. And the other angle would be BCE. Okay? So we've got both of our angles, and together they're going to add up to make a straight line, or 180 degrees. So we've got the measure of angle BCE plus the measure of angle ECD will give us 180 degrees. Okay? Now, let's go ahead and find the measure of those added together. So we've got the measure of angle BCE is 4x plus 8 plus the measure of ECD is x plus 2. Remember, whenever we're plugging in for plug and chug, we always plug in with parentheses around whatever we're plugging in for, okay? Equals 180 degrees. Now, let's go ahead and get those parentheses away. So we've got 4x plus 8 plus x plus 2 equals 180 degrees. Now, what we have to do next is find our common terms and add them. So I see x's here. We can add those together. 4x plus x becomes 5x. And then I also see the 8 and the 2. we can add those together. 8 plus 2 is plus 10, and that's going to equal 180 degrees. Now, what we want to do is get all the numbers on one side and all the variables on the other. So what we have to do is subtract 10 from both sides. This is going to give us a cancellation of the 10 plus 10 minus 10, so we get 5x equals 170 degrees. Now our next step, remember, if we have 5 times x, in order to get rid of the 5, because we want x alone, we have to do the opposite operation. So for multiplication, that would mean we would have to divide. So we're going to divide by 5. That way the 5s will cancel, and we're going to be left with x equals 170 divided by 5. I'm not that smart. I need to use my calculator. So let me pull that out. 170 divided by 5 is 34. So x is 34 degrees. But that is not what it was asking. It says find the measure of BCE. So in blue, I'm going to find the measure of BCE. We know that the measure of BCE is 4x plus 8. But now we know that what x is. X is 34. So now the measure is 4. Remember, when we're plugging in, we're putting parentheses around it. 34 plus 8. 4 times 34 is 136 plus 8. 144 degrees. And for angle ECD, measure of angle ECD is x plus 2. Now we know that x plus 2 is 34. I'm sorry, x is 34. We add 2 to that, and we're going to get 36 degrees. Now, if we did 144 and we added 36 to that, we should get 180 degrees, and we know we did our answer correctly, okay? So this example was, it gave you two angles, which we didn't know what they were. They were in terms of x. But what it did tell us was that together they are supplementary. So that means when you add them together, we're going to get 180 degrees. So that's what we did. Once we got 180 degrees, once we had this equation, then we could solve for x. Once we found x, we could find the measure of each of the angles, okay? All right, linear and vertical angles. So linear pair are two adjacent angles when non-common sides are opposite rays, always form supplementary angles. So linear angles, that's key. Always form supplementary angles. And vertical angles are two angles whose sides form two pairs of opposite rays. So linear pairs are like this, okay? They are right next to each other, they are supplementary, and they are adjacent, okay? Remember, no, angles don't have to be adjacent to be supplementary, okay? But for linear, they do. And then 3 and 6 are vertical angles, and 4 and 5 are vertical angles, okay? That means that they're basically across from each other. And we'll do a lot of examples with this. It'll make a lot more sense. But what you basically need to know is that vertical are across, and linear, they are next to each other, forming a straight line. Okay? So in this portion, you could say that angle 3 and angle 4 are linear. Because if we drew a line from 3 to where 4 ends, we end up with a straight line. We could also say that 4 and 6 are linear, 5 and 6 are linear, 5 and 3 are linear, okay? And then the vertical ones are the ones that are across from each other. Okay, Two angles form a linear pair. The measure of each angle is 5 times the measure of the other. Find the measure of each angle. So I am a very visual person, as I've told you guys a million times. So I'm going to go ahead and draw a picture. So we've got two angles and they form a linear pair. So remember, they're going to form a line. Linear line. Let's put our vertex right here. And we've got the measure of one angle is 5 times the measure of the other. So let's see this. And we know that, let's say x is the measure of one angle, the smaller angle, okay? So let's put x here. It says the other one is 5 times the measure of the other. So this one's going to be 5x. Find the measure of each angle, okay? So let's go ahead and solve this. Now, linear angles add up to be a straight line or 180 degrees. So knowing this, we know that when we add 5x plus x, we're going to get 180 degrees. Now 5x and x can be combined to give us 6x, and that's 180. You can divide by 6 to both sides, and you'll be left with x equals 30. Okay? Whoa, I don't know what just happened. Okay, there we go. Now that we know x equals 30, the measure of one angle is 30 degrees, and the other is 150 degrees. Okay, how do we get 150? If 1 is 30, then you plug in the x equals 30 for the 5x, and you're going to get 5 times 30, which gives us 150 degrees. Okay? Example 4. Again, guys, these examples are super critical, okay? These are ways to do the problem that will help you guys a lot, okay? So the measure of an angle is twice the measure of its complement. Find the measure of each angle. So I, again, am a very visual person. So it says complements. Complements are the right thing to do. So we're going to draw a right angle. Okay. And now it says the measure of an angle is twice the measure of its complement. Find the measure of each angle. So we know that one's going to be small and the other one's going to be big. The smaller one, again, we will label x. And the larger one, we will label 2 times x because it says it's twice the measure. So whenever we have complements, they are going to add up to be 90 degrees. So let's do x. Oh, that's a really bad x. X plus 2x equals 90 degrees. Okay, x plus 2x becomes 3x, and that's going to be equal to 90 degrees. We want to divide by 3 to get rid of these so that we can have x by itself. So x equals 90 divided by 3 is just 30 degrees. So the measure of each angle, one angle is 30 degrees. And the other is 60 degrees. Because if one is 30, in order to get to 90, you have to add 60, or you could have just plugged x equals 30 into our 2x portion for the second angle. Okay? All right, interpreting a diagram. There are some things you can conclude from a diagram and some you cannot. For example, here are some things that you can conclude from the diagram on the right. All points shown are coplanar. Absolutely right. If it was not coplanar, you would either see a dotted line or something else, okay? Showing you that it is three-dimensional. All right, and then points A, B, and C are collinear. That's true, because they're all on the same line. B is between A and C. Absolutely. AC, the line, BD, and BE intersect all at the point B. That is correct. The angle DBE and EBC are adjacent angles, and ABC is a straight angle. Very good. So point E lies in the interior of DBC. Okay? In the diagram above, you cannot conclude that AB is congruent with BC. So that means that the distance here is not the same as the distance here. It would have to tell you, it would have to have these marks. Since it doesn't, we cannot assume that, okay? It also says that you can't assume that the angle DBE, that's this one right here, is the same or congruent to the angle EBC. That's correct. We don't know that. If they had this, what I just wrote down, two arcs in each of them, then yes, you would be able to conclude it. You can't conclude that ABD is a right angle. It must be indicated, okay, as shown on the right. So these are some things that if they were shown would tell us this, okay? So having these hash marks and these angle congruence angle marks and then the right angle mark, those would help us assume certain things about the problem. Otherwise, we cannot assume them, okay? Okay, let's use each diagram to solve for the indicated angle measures. All right, so the measure of EFH we have to find. We know that it's equal to 3x minus 6, but in order to find what x is, what do we have to do? Well, we know that from E to G, that's a straight line. Whenever we have a straight line, it's 180 degrees. Oops, not 18 degrees, 180 degrees, and they are supplementary, okay? So for A, 180 is going to be equal to 3x minus 6 plus 2x plus 16. Because going from here to here and then all the way to here, we get a straight line, okay? Following that angle all the way around. So let's go ahead and solve this. So it's going to be 180 equals 3x minus 6 plus 2x plus 16. 180 equals, the 3x and the 5x combined to give us 5x. The minus 6 and the plus 16 will give us plus 10. Now we can subtract 10 from both sides. 170 equals 5x, and then divide by 5, and we're going to get x equals, I thought we already did 170 divided by 5. We did at 34. 34, okay? So now it says we only want the measure of EFH. EFH is right here. So let's go ahead and find that. And how we find it is we plug in x equals 34 for 3x minus 6. So 3 times 34 minus 6. 3 times 34 is 102. You subtract 6 from that and you get 96 degrees equals the measure of angle EFH. All right. So there's A. Let's try B. Find the measure of ABC. That's this one right here, okay? Because it's pointing to our angle A to B to C, okay? All right, but what do we know? We know that ABD is a right angle. We know that from here. How do we know that? Because of this little box here, okay? So we know that 90 degrees must be equal to x plus 9 plus 2x. Because if we take this angle and we add this angle to it, we end up with 90 degrees in total. They are complementary, okay? So x plus 9 plus 2x, we're going to go ahead and add those. So 90 equals 3x plus 9. We subtract 9 from both sides. You get 81 equals 3x. If we divide both sides by 3, we get x equals 81 divided by 3 is 27. And it wants us to find the measure of ABC, which is ABC. That's this angle right here. And that would be x plus 9. So we're going to go ahead and plug in 27. So 27 plus 9 is 36. And that's the measure of angle ABC. Okay? Those were all the notes for today. If you guys have any questions, let me know. Again, thanks for tuning in, and I'll see you guys tomorrow.